Hello everybody, welcome back to the Learning Management System initiative of the Department of Collegiate and Technical Education. You all know that myself, Rekha T, is handling the course Particulate Technology for the third semester Chemical Engineering students of the institute. So we already have completed 9 sessions of the first unit, that is size reduction. So today we shall have the 10th and the final session of Unit 1. So, before we actually start discussions of the topics planned for today's session, let us first go back and see what we learned in the previous session. So, in the last session, we understood what is meant by critical speed of the ball mill and how the variation in speed of the mill affects the performance, that is, how it changes or influences the action taking place inside the ball mill. So we also learned how to calculate the critical speed of the ball mill, which in turn helps us estimate the operating speed of the mill for a given size reduction duty. So these are the topics that we are taking up today. So first we'll learn what is meant by grinding aid and what are the advantages of using grinding aids in a grinding operation. So later we'll take up the ultrafine grinders. So first we'll understand their general principle of working and the important ultrafine grinders. Then after that we'll take up one ultrafine grinder, that is fluid energy mill, to study its construction, operational details and application in detail. So what is a grinding aid? A grinding aid is that substance which when added to mill charge in a very small quantity helps in increasing the grinding efficiency and also helps in reduce the power consumption for the given operation of grinding. Okay, some organic materials like polyols, alcohols, esters, amines, and some of the inorganic compounds like calcium chloride, then sodium chloride, sodium silicate, sodium carbonate, etc., are used as grinding aids. So they are usually added in a very small quantity of around 0.28% and below to the feed that enters the mill. So where it increases the grinding efficiency by enhancing the following things. The grinding aids increase the efficiency of grinding and it reduces the usage of water. Then the material flowability also increases by the addition of these agents. Then the particle size distribution of the grinding products also maintained very narrow by the use of grinding aids. So these are some of the advantages of using the grinding aids in a grinding operation. So with that, let us move on to the next topic, that is ultrafine grinders. So what is the requirement of an ultrafine grinder? So many commercial products need to be in a size in the range of around 1 to 20 microns. So we need equipments to reduce the size of the product to such a small size, and equipments that are employed for this duty are called ultrafine grinders. So we have different types of ultrafine grinders. The important ones that are used are hammer mills with internal or external classification, then fluid energy mill, also called as jet mills. Then we have agitated mills. So among these three, the first two, hammer mills with internal or external classification and fluid energy mills, are used to produce dry powders, whereas the agitated mills are used for wet ultrafine grinding. So let us now discuss about the fluid energy mill. So one thing we should remember is all the ultrafine grinders employ attrition as a main mechanism for size reduction. So a fluid energy mill employs attrition, and let impact to some extent to reduce the size of the particles in the operation. So it mainly uses a source of compressed air or gas or a superheated high pressure steam that enters the mill through nozzles at a very high velocity that actually provides the energy to the particles to attain a great velocity. So the particles will be moving with such a great velocity inside the equipment. So during that movement, they strike against each other and attrition and impact results, thereby breaking the particles in size to lower micron size. So one important thing about a fluid energy mill is that it has no moving parts, so no grinding media. So wearing out of the parts of the mill is not present in this type of equipment. So coming to the construction of a fluid energy mill, it mainly consists of a loop of pipe of oval shape as shown in figure. The pipe diameter is between 25 to 200 millimeters and the height of the loop is around 2 meters. Then it is provided with tangentially arranged jet nozzles at the bottom of the mill for introducing the high pressure steam or air or any other inert gas to create a high speed inside the equipment. The energy for size reduction is supplied by this source of compressed air or superheated steam. It also employs a classifier at the center which allows only the gas to pass out of the chamber and prevent the particles from escaping out along with this gas until they are reduced to sufficiently fine size. Okay. So this that is the arrangement of the different parts of a fluid energy mill. So coming to its operation, the compressed air or gas that are issued through the nozzles form a very high velocity tangential circle within the grinding chamber. The material that is to be ground is also fed into the same tangential circle through a venturi feeder as shown in diagram. The material in the circle gets rapidly accelerated and due to this rapid movement they strike against each other and attrition and impact results by which the particle rises, gets reduced to lower micron size. The particles which are larger in size are held towards the periphery of the pipe. So due to their more large size and due to the action of centrifugal force, while the particle of smaller size travel in the spiral movement towards the central outlet from where they exit into the cyclone below the bottom discharge. So this is a pic showing the actual view of a few designs of fluid energy mill. So coming to the applications of fluid energy mill. So fluid energy mill can handle particles of size ranging from 150 microns and they can grind up to the size of 1 micron. So usually the powders from pulverizers, that is fine grinders, are handled in this type of machines. The type of products that are usually processed in this type of equipment are food products, antibiotics, pigments, dyes, cosmetics, etc. So what are the advantages of fluid mill over the other type of grinding equipments? So here we can reduce the material particle size to a very fine size, and the particle size can also be controlled because we have an arrangement of a classifier. So no wear and tear of the grinding parts inside the equipment. So the product contamination is not present in this type of equipment. So this is also suitable for a very sensitive material because there are no grinding elements or the grinding media involved in this one. So heat generation due to friction is less. So as a result of which the heat sensitive materials can be safely handled in this type of machine. So that completes our discussion on size reduction. So this is a YouTube video link that provides you an opportunity to view a video to enhance your understanding about the working of a fluid energy mill. So this is a session recap. So thank you for listening.